Good morning students. Today fourth one, distance between 2 points in coordinate geometry. If x1 y1 and x2 y2 are 2 points on a straight line, then the distance between 2 points will be AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. To prove distance between 2 points, you should understand what is Pythagoras theorem. What is Pythagoras theorem? In a right angle triangle, I have given right angle triangle. The square of the length of the hypotenuse is equal to the sum of the squares of length of other two sides. What do I have to prove? Hypotenuse square is equal to opposite side square plus adjacent side square. What is Pythagoras theorem? The square of the hypotenuse is equal to sum of the squares of other two sides. Other two sides will be opposite side and adjacent side. Pythagoras theorem. This is also called Buddhayan theorem. To prove Pythagoras theorem, we have many methods. I will tell you simple method. Opposite to 90 degrees, this is hypotenuse, and this is, if you take this is theta, opposite side, and this is adjacent side. You take, this is 3 centimeters, 3 units, 3 centimeters, and you take this as 4 centimeters, and hypotenuse. What is the hypotenuse? 3, 4, this will be, what is Pythagoras theorem? In a right angle triangle, the square of the hypotenuse is equal to sum of the squares of other two sides. You take 1, 2, means it is divided into you take this 4, this you take this as 4, 1, 2, 3 you take, and 1, 2, 3, it becomes 4, and this is 5. One, 2, 3, 4 you take. Here also you take 4. 1, 2, 3, 4 you take. See, what is Pythagoras theorem? Square of the hypotenuse is equal to sum of the squares of other two sides. Square of the hypotenuse means hypotenuse square means that is 5 square. This, what is the area of this square? That is 5 square. It will have 25 squares. Now, is equal to sum of the squares of other two sides. What is opposite side? 3 units. Means 3 square. Means area of the opposite side, that is square. The area will be 3 square. Means 9. Plus, what is the area of this adjacent side? That is 4 square. Square of the hypotenuse is equal to sum of the squares of other two sides. This is a simple example. We have many methods for Pythagoras theorem. I am telling you a simple method. 5 square. What is LHS here? You take LHS. 5 square means 25. RHS you take. We have to prove LHS is equal to RHS. Plus 4 square you take. 3 square means 9. 4 square means 16 is equal to 9 plus 16, you will get 25. See, in a right angle triangle, square of the hypotenuse is equal to sum of the squares of other two sides. On the squares, it will be 9. 9 plus this will be 16. 9 plus 16, 25. This will be 25 squares. You will have many examples for Pythagoras theorem. 3, 4, 5 you can take. 3 2s are 6, 4 2s are 8, 5 2s are 10. And also you can take 3 3s are 9, 4 3s are 12, 5 3s are 15. You take 3 4s are 12, 4 4s are 16, 5 4s are 20. These are the examples of Pythagoras theorem. 3 square plus 4 square is equal to 5 square. 6 square plus 8 square is equal to 10 square. 9 square plus 12 square is equal to 15 square. 12 square plus 16 square is equal to 20 square. Like that you can have many examples for Pythagoras theorem. Now we will go to the distance between 2 points. Now distance between 2 points. If x1, y1 and x2, y2 are 2 points on a straight line, then the distance between 2 points, that is A and B, will be root of x2 minus x1 plus y2 minus y1 whole square. We have to prove that one. To prove that one, we have to understand Pythagoras theorem. Already I told you what is Pythagoras theorem. Now this is x-axis and this is y-axis. You have to take 2 points in a straight line. You take a straight line. You have to take 2 points on a straight line. This is a straight line. You have to take 2 points on a straight line. You take this A, x1, y1. Point A, that is x1, y1. You take a point B, that is x2, y2. I have to take 2 points in a straight line, that is x1, y1 and x2, y2. We have to find the distance between these 2 points. Make it as hypotenuse. Think this is hypotenuse. We have to draw a right angle triangle, making it as hypotenuse. Opposite to 90 degrees, that is hypotenuse. You draw a right angle triangle. This will be hypotenuse. And if you take this as theta, this is opposite side and this is adjacent side and this is 90 degrees. Opposite to 90 degrees, that is hypotenuse. This is angle theta. The angle made by this straight line with positive direction of x-axis in anti-clockwise direction is theta. Opposite to theta is opposite side. Adjacent to theta is adjacent side. This will be hypotenuse. Now we have to prove AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now first you have to write Pythagoras theorem. What is Pythagoras theorem? The square of the hypotenuse is equal to sum of the squares of other two sides. Means hypotenuse square is equal to opposite side square plus adjacent side square. Now AB square is equal to, what is opposite side? What is hypotenuse? That is AB square is equal to opposite side AB, you take this as C. BC square, opposite side will be BC square. What is adjacent side? That will be AC is equal to AC square. Now we have to find AB. Now AB is equal to square root of BC square plus AC square. First, what is BC and what is AC? We have to write. First, identify C. Point A is x1, y1 means this distance is x1 and this distance will be y1. B means x2, y2 means x. This distance is horizontal distance is x2 and vertical distance will be y2. You take like this. This distance we have to take from this one, that is x2, comma. We have to find this distance. We have to write y coordinate. Y coordinate will be, this distance will be y1. Point C will be x2, y1. What is BC? Vertical distance. We have to write vertical distance. BC is equal to vertical distance. This is y2 and this is y1. This distance opposite side will be y2 minus y1. BC is equal to y2 minus y1 and BC square is equal to y2 minus y1 whole square. Now you write AC. What is AC? What is the distance between A and C? A and C, that is horizontal distance. This distance will be x2 and this distance will be x1. This distance will be x2 minus x1. Like that, AC will be x2 minus x1. AC square will be x2 minus x1 whole square. Now, AB is equal to square root of, what is BC? Y2 minus Y1 whole square plus what is AC? AC is x2 minus x1. AC square is x2 minus x1 whole square. Now AB is equal to square root of x2 minus x1 plus y2 minus y1 whole square. The distance between 2 points, that is AB, will be square root of x2 minus x1 whole square plus y2 minus y1 whole square. What is the use of finding the distance between 2 points? In introduction, I have already told you we can find the distance between 2 points. How Google Maps works. We can find out the distance between 2 points by GPS system. I have already told you in introduction. Now I will take one example. What is the use of distance between 2 points? Now I have taken one example. Show that the points minus 5, minus 3, 1, minus 11, 7, minus 6 and 1, 2 are the vertices of a parallelogram. Check whether the diagonals of parallelogram are equal. They are equal or not, we have to check. First you should know properties of parallelogram. What are the properties of parallelogram? Properties of parallelogram. Opposite sides are equal and opposite sides are parallel. First you take a parallelogram. I will take A, B, C, D. You have to take like this or like this. What is A? You take minus 5, minus 3. And what is B? 1 minus 11. What is C? 7 minus 6. What is D? 1 comma 2. These are the vertices of a parallelogram. We have to check whether the opposite sides are equal or not by using distance between 2 points. What is the formula for a distance between 2 points? AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, first you find the distance between A and B and D and C. What is the distance between A, B? Square root of, you take this is x1, y1 and this is x2, y2. This is x1, y1 and this is x2, y2. x2 minus x1 whole square means 1 minus of minus 5. 1 minus of minus 5 whole square plus next y2 minus y1 whole square. Minus 11 minus of minus 3. Minus 11 minus of minus 3 whole square. 1 plus 5. 1 plus 5 whole square means 6 square plus minus 11 plus 3 minus 8 whole square is equal to square root of 6 square means 36, 8 square means 64 and root 100 is equal to 10. What is the distance between A and B? That is 10 units. Now you find the distance between C and D. CD is equal to x2 minus x1. This is x1 y1 and this is x2 y2. x2 minus x1 means 7 minus 1 whole square plus y2 minus y1 whole square minus 6 minus 2 whole square minus 6 minus 2 whole square. 7 minus 1 6 square means you will get 36 plus minus 6 minus 2 minus 8 whole square, that will be 64. 8 square is equal to 64 and you will get root of 100. Root of 100 means plus or minus 10, but you have to take 10 plus 10 because the distance will be in positive is equal to 10. As see, AB opposite sides are equal to each other. We represent like this. Opposite side, this is AB is 10 and this is 10 units. Opposite sides are equal. Now, what is the next pair of opposite sides? AD and CB, BC. and I will find AD here. AD is equal to root of x1 y1 x2 y2. You can take x1 y1 this one and x2 y2 this one, no problem. You take this x1 y1 and this is x2 y2. x2 minus x1, 1 minus of minus 5 whole square plus y2 minus y1 whole square, 2 minus of minus 3 whole square is equal to 1 plus 5 whole square means 6 square plus 2 minus of minus 3, minus into minus plus 2 plus 3, 5 square. You take 5 square, square root of 36 plus 25. You will get 36 plus 25, that is root, you will get 61. Now we will find the distance between, this is root 61. This is root 61. This must be root 61. We will find BC is equal to root of x2 minus x1 whole square, means you can take x1 y1 this one, x2 y2 means 7 minus root of 7 minus 1 whole square plus minus 6 minus 11, minus 6 minus of minus 11 whole square. You will get 7 minus 1 means 6 square. 6 square means 36 plus minus 6 plus 11. You will get 5 square means 25. You will get root of 36 plus 25. You will get root 61. Root of 36 plus 25, root 61. As you got BC is equal to root 61. See, opposite sides are equal. AB is equal to CD. And what is another pair of opposite sides? AD and BC. That's why opposite sides of a parallelogram are equal to each other. As these are the vertices of a parallelogram. Now we have to check whether the diagonals of parallelogram equal. We have to check. You see, by using distance between 2 points. First we will find the distance between A and C, diagonals. AC is equal to, this is x1 y1 and this is x2 y2. 7 minus of minus 5, root of 7 minus of minus 5 whole square plus minus 6 minus of minus 3, minus 6 minus of minus 3 whole square. We have to extend. Root of 7 plus 5 whole square. 7 plus 5 means 12. 12 square means 144 plus minus 6 plus 3 means minus 3 square means you will get 9. Root of, you add these two, 153, root of 153. What is the diagonal? The AC will be root of 153. We have to find the distance between B and D, whether the diagonals are equal or not. We have to check. We have to find the distance between BD. BD is equal to square root of, this is x1 y1 and this is x2 y2. x2 minus x1 whole square means 1 minus 1 whole square plus y2 minus y1 whole square, minus 11 minus 2 whole square, minus 11 minus 2 whole square is equal to 1 minus 1 means 0 square means 0, minus 11 minus 2 means minus 13 whole square means root of 13. 13 square. What is 13 square? 169. Root of 169. You will get 13. Root of 169 and root of 153. They are not equal to each other. Therefore, diagonals of parallelogram are not equal to each other. As these are the vertices of, what is the first answer? Yes. given vertices are vertices of parallelogram. Check whether the diagonals are equal or not. Diagonals of parallelogram are not equal to each other. Remember, diagonals of parallelogram are not equal to each other. By taking distance between 2 points, we can check whether the diagonals are equal or not, whether the opposite sides are equal or not, but we can check. Like this, distance between 2 points very useful, and also it will be useful in Google Maps. Distance between 2 points is 3b, not 4.